In this video, I'm going to show you how you can write a quadratic from standard form to vertex form. And there'll be two methods I'll show you. So method one, I have my quadratic. My quadratic is y equals 2x squared plus 6x minus 8. My first method, I'm going to get that 8 to the other side. So to do that, I'm going to be adding 8 to both sides. So I'm going to have y plus 8 plus blank equals, and then over here, I have here where I'm going to factor out a 2. So I have a 2, and then I have an x squared plus 6 divided by 2 would be 3x, and then plus blank. Now the reason why I'm taking out the 2, factoring out 2, is so I can complete the square. And you can only complete the square if your quadratic, or your x squared, is a 1x squared. So once I do that, now I take my b, which is 3. I take half of 3, which is 3 squared, or not 3 squared, 3 halves. So I have 3 halves, and then I square it. So 3 halves squared would be 9/4, and 9/4 would be 2.25. So this would be 2.25 in here. But I'm really not adding 2.25 on both sides because I factored out a 2. So I got to take the 2.25 and multiply that by 2, and that's a 4.5. So what I'm really doing is adding 4.5 to both sides. And now from here, I can simplify. Y plus 8 plus 4.5 is y plus 12.5 equals, and on this side I have 2 parentheses, and I have a perfect square trinomial here, which I would take the square root of x squared, which is x. I use the plus sign, the same sign that's there, and then it's really taking half of 3, which I'm going to put it as a decimal, which that would be 1.5. Or you can think of it as take the square root of 2.25, which is 1.5, and then this is a square. So that's a perfect square trinomial, or a binomial squared. All I have to do is get y by itself. So I'm going to subtract 12.5 on both sides. And so my answer would be, in vertex form, y equaling 2 times x plus 1.5 squared minus 12.5. And I would say my vertex would be negative 1.5 and a negative 12.5. Keep in mind, in here, my h and k, so my h in the normal form is x minus h. If I have a plus sign here, that means x minus a negative h. So that's why I would have a negative 1.5. So that is method one. Method two would be very similar, except for I'm not going to move my h to the other side with a y. So I'm going to start off with y equals, and I have 2x squared plus 6x, and then I'm going to have that in parentheses, and I'm going to put the minus 8 on the outside. Now this minus 8 on the outside, think of this as like it's on the other side of the equal sign with the y. But I'm going to do the same steps as what I just did in front of the parentheses. So I'm going to factor out a 2. So right now, if I factor out a 2, I'm left with x squared plus half of 6 is 3. That's 3x plus blank. And then I have a minus 8, and I'm going to put a plus blank on the outside here. Now I need to complete the square here. So to complete the square, I'm going to take my b, which is 3, divided that in half, which is 1.5, and I square it, and that gives me 2.25. So this is 2.25. But because I factored out a 2, I got to multiply that 2.25 times 2, which will give me 4.5, and 4.5, since I'm adding 4.5 on the inside, I have to do the opposite on the outside, which that means I'm subtracting 4.5 out here. And now I can write my equation in vertex form, which would be y equals 2 times, and then I make this as a perfect squared, as a binomial squared, which would be x plus 1.5 squared. And then out here, I have negative 8 plus a negative 4.5, which is a negative 12.5, which is what I had on the other side in method 1. So my vertex will still be negative 1.5 and negative 12.5. That is an example where the leading coefficient is bigger than 1. Let's try another example. This time, our x squared is just 1x squared. And I'll show you both methods to doing this one. So first thing we're going to do is we're going to write this as y equals, this would be x squared minus 2x minus 7. Now method 1 will be like the last one I did with method 1. So here I'm going to add 7 to both sides. And now I have y plus 7 plus blank equals, and now here I don't need to factor anything out. So I have an x squared minus 2x plus blank. And I'm going to take my b, which is negative 2, divide that in half, which is negative 1. I'm going to square that, and that gives me a positive 1. So this is a positive 1. And because I added 1 to this side, to make it equation still equal, I have to add 1 to this other side. So that is the difference between method 1 and method 2. Method 1, whatever I add on one side, I add on the other side. Method 2, if I add 1 on the inside of the parentheses, I have to add the opposites on the outside of the parentheses. So now what I have right now would be y plus 8 equals, and this is a perfect square trinomial, which I can write this as x minus, and then half of 2 is 1 squared. Then to get to y by itself, I would subtract 8, and I would have an equation in vertex form as y equals x minus 1 squared minus 8. And my vertex would be, since I have x minus 1, think of that as x minus h. My h would be a 1, and my k would be a negative 8. So my vertex would be at 1, negative 8. Now if I take the same equation, but now I use method 2. So method 2, I'm going to start off with y equals, and I have x squared minus 2x, but I'm going to have this in parentheses, and then I have the minus 7 on the outside. So I need to complete the square on the inside. So this is going to be x squared minus 2x plus blank minus 7 on the outside plus blank. So my b is negative 2. Divide that by 2. That gives us negative 1. Square that, and that gives us 1. So I have a 1 out here. Since I don't have a number besides a 1 on the outside here, it's just going to be 1. But because it's on the inside of the parentheses, I have to do the opposite on the outside. So I'm going to subtract 1 here. And now I have everything I need to write my equation, which would be y equals, write this as a perfect square, like a binomial squared, which would be x minus 1 squared, and then negative 1 plus a negative, or negative 7 plus a negative 1 is a negative 8. And I have the same equation with the vertex still being at 1, negative 8. That is how you can write a quadratic from standard form to vertex form.